In this video, once again, we are just looking at graphing a function, very specifically a cubic function based off of its transformations. This one looks slightly different than some of the ones we've done before, because when I go to find kind of this like point of inflection, I notice that I just have x cubed. There aren't any parentheses here, which means that there's nothing else that is going on with this x value. And so really, that means that inside value is going to be 0. And then I have this 1 on the outside. And so I think that's probably going to be my point in inflection, but I also notice this information here. So we're going to kind of see, does that hold out or not? And so because there are no parentheses, like an x minus 1 or something, there is nothing else that is being cubed. Everything is happening before we cube our value. And so that means everything on the outside is actually dealing with my y values. So when I come over here to transform it, well, in the x, there is no change. My x values are not changing for this one. And the y, I know that it's going to be reflected, it's going to be stretched, and it's going to be shifted. And so what that really ends up looking like, so I'm going to take all my y values, do negative 2 y plus 1. So I'm going to do the exactly what I have in my formula. I'm going to do the negative 2 to my y value, and then I'm going to add 1. So there's multiple things that are happening to my y values, whereas nothing is happening to my x values. I'm going to keep my x values exactly what they are. And then for my y values, the first thing I'm going to do is negative 2 times negative 8, that's positive 16, and then plus 1. So that gives me a 17. I'm not even going to be able to graph that point. Same thing, I'm going to take negative 1 times negative 2, that's positive 2, plus 1, that's going to give me a 3. If I keep this out, so 0 times 2, 0 plus 1 is 1. Ooh, I did see that 0, 1 point, so I was on something. Next, I get negative 2 plus 1, that's negative 1. And I get negative 16 plus 1, and that's me negative 15. So if I try and plot these, my 0, 1 is that point of inflection. And then I have negative 1, 3. And then I have negative 2. Well, 17 is me way up here. I'm not going to be able to get to it. I then have 1, negative 1, and 2, negative 15 down there. I'm going to have a hard time getting to that as well. But I can still kind of get this sketch because I know that this is my point of inflection. So I know that when I get here, this is where I need to curve up. But I notice I'm not curving up to the right, so my point's in there. I'm curving up to the left because of that reflection. So I'm going to curve this up, and I'm going to try to get to that point. And then same thing, I'm going to curve down on the other side. I'm going to try that curve a little bit better. I'm going to curve down on the other side and try to get to that point. Never quite actually getting there. So I can see that this one, because there was the negative, it's going in that opposite direction. Because there's this 2, my points are even further away. My y values have been stretched, but I still was shifted up 1. And very specifically, I can notice because there was no parentheses around the cube, I know that there's nothing going on with the x direction. Everything is outside of the cube. The only thing that's being cubed is x, so everything else has to deal with the y direction. And there you have it, one other example of how to use transformations to help me graph a cubic function.